worry about that. But sine and cosine, and tangent and the other one, cosine, I do that sometimes, are periodic, okay? Periodic, which means they repeat. Okay? Right, they repeat. Every how long? For sine and cosine?
Every 2 pi.
2 pi, okay? So period equals 2 pi. We will learn later sine and cosine. So are sine and cosine are periodic. That means that cosecant and secant have to be periodic. But tangents and cotangent are also periodic. And we'll talk are also periodic. Periodic. But their period is different. Periodic. Okay? Period equals, does anyone know from your unit circle? If you look, it's very good. Okay? So tangent and cotangent are periodic, but they repeat every pi. So if you're in tangent, in other words, if you look at tangent of pi over 4, for instance, and that's a 45-degree angle. Tangent of pi over 4, at that point, remember on your unit circle, it's root of 2, right? What's the tangent of pi over 4? 1, okay? So that's equal to 1. And then back over here, okay, what's the tangent of 3 pi over 4? I mean, not 3 pi over 4, that'd be 5 pi over 4, away from there. It's not negative 1, because that's the point negative root of 2, comma, negative root of 2 over 2. Okay, so it's y over x, which is also, tangent here is also positive. Tangent of 5 pi over 4 is also equal to positive 1. So tangent repeats itself. So if you add 180 degrees or pi radians to a tangent function or a cotangent function, you'll get out the same value. If you have a sine function, cosine function, you add 2 pi to it, or 360 degrees, you'll also get out the same value. Okay? So, and we talked about some of this because I assigned some kind of ahead of before you did it. But so if I wanted to do, for instance, the cosine of 100 pi, oh my God, I don't know how to do that. How many times is it going to repeat? 50. It's going to repeat exactly 50 times. So if I were to start here, it would go around the circle, right? I could divide that by 2 pi and say, oh, it's going to do 50 revolutions, right? So it's going to end up where? Right there. What's the cosine of 100 pi?
0.
1. Okay? So that's equal to, because it's going to end up back here again. So it's going to, so the point here is 1 comma 0. So cosine is the x coordinate. So that's equal to 1. Yes. Okay? Easy. Right, that's examining some of the periodic behavior. Let's do a slightly more complicated one. And I did one like this already, but say I were to ask you, what is the sine of 63 pi over 6? Good. Who can tell me how to do that? 63 pi over 6. Yes, sir.
So you take out 65?
You take out 60 pi.
You have like 10 revolutions? Does that make sense?
10. Well, you'd have 10 pi. What I would do, yeah, I understand.
You get what I'm trying to say?
Yeah, but it'd be,
It'd be 5 revolutions.
if you divide,
So do you 60 pi divided by 6? That's what I do. And then you have 3 pi divided by 6.
you have 3 pi. So you do 60 pi
Yeah.
divided by 6,
Yeah, so you have 10
which
pi.
is 10 pi,
So 5
which is
revolutions.
5 revolutions.
And you have 3 pi or 6 pi.
And you have, so you go around 60 and you'd have
You go
3
around
pi over 6 left.
And
which is the same as pi over 2. So you'd have the sine of pi over 2, which is 90 degrees. Good. That's one way to think of it. Okay. What I can never think of a perfect method to do this, but what I would do, I know that 63. I'm gonna see how many times 12 pi. So 12 pi over 6 is equal to 2 pi, right? So 12 pi over 6 is 1 revolution. So what I'm going to do, I'm going to take 12 pi, I'm going to take 12 pi and divide it into 63 pi. Okay, so how many times is 12 going to 63? You don't have to worry about the pi's, right? So 5 with a remainder of 3 pi's over 6. You see? So if I divide 12 pi's over 6 into this, I go around 5 times with 3 pi over 6 left over, which again is pi over 2, and then I take the sine or cosine of that. Okay, and so I kind of tend to think in, like they say, 83 pi's over 4. I go, well, 1 revolution is 8 pi's over 4, right? And then I see how many times does 8 go into 83, right? And then my remainder is 3 pi's over 4, and that would give me the, you understand? Maybe you'll get some practice. Okay. The other thing with these functions, the even and odd properties, which I didn't talk about. So even functions and odd. So the even trig functions are just cosine, and sine. And what that means is if I plug in a negative value, cosine of negative t is equal to the cosine of positive t. And that's wrong. Shouldn't have been sine, I should have said secant. Secant of negative t is equal to the secant of positive t. In other words, as an example, okay, the cosine of negative 30 degrees is equal to the cosine of positive 30 degrees. Okay? So over here, because look, if I go negative 30 over here and positive 30 over here, what's going to be true about the x values in both cases? It's the same, okay? And that's why cosine is even and its reciprocal is also even, right? Sine, its reciprocal cosecant, tangent, and its reciprocal cotangent are odd, okay? Which means sine of negative t equals negative sine of t, or cosecant of negative t equals negative cosecant of t, and tangent of negative t equals negative tangent of t, and so forth. And cotangent of negative t equals negative tangent of t. So if they said something, let's do a tricky one. Find the cotangent.
I'm confused.
What?
Why is the cotangent negative t equal to negative tangent of t?
I'll show you. Okay. So if, for example, say I did cotangent of negative 3 pi over 4, that's equal to negative cotangent of 3 pi over 4. That's what that.
Did you write it wrong?
Did I write? Oh, sorry.
Yes.
Yeah, I was confused why you were confused. Okay. Yeah, sorry. Negative cotangent of t. Sorry. Okay. Cotangent of t. Like that. So in other words, cotangent 3 pi over 4 is negative 3 pi over 4 would put me in which quadrant? Which quadrant would negative 3 pi over 4 put me in, Tyler? How's your cell phone doing? Okay. Where would negative 3 pi over 4 put me?
Second.
Third quadrant. Good. Because this is pi over 4 negative, right? This is 2 pi over 4. This would be negative 3 pi over 4. Okay? So cotangent negative 3 pi over 4 is over here. And the coordinates at that point are, what are the points? What are the coordinates at that point? When it's isosceles triangle, so what are the coordinates right there? Look on your unit circle that you made. Negative root of 2 over 2, comma, negative root of 2 over 2. Right? Okay? What? Oh, sorry. Negative root of 2 over 2. Right? Okay? So then, to figure out cotangent of negative 3 pi over 4, I could just go positive cotangent of 3 pi over 4. And why would you want to do this? It's a little easier because you don't have to go in the negative direction. So the negative cotangent of that should be the same as the tangent of this. So what is the cotangent of negative 3 pi over 4? What's the ratio of x to y? Because that's what cotangent is. What is x over y in this case? X over y. 1. So this is equal to positive 1. And this is equal to negative cotangent of 3 pi over 4. What is tangent of positive tangent? What is tangent of positive 3 pi over 4? Negative. Okay? That's negative 1 because this point, remember, is negative root of 2 over 2, comma, root of 2 over 2, right? And so negative 1 also gives you positive 1. See the way that works? Okay? All right? And that's what and then all we have to do is do some, how you do this stuff with your calculator, which I don't want you to do, because on a quiz tomorrow, you're not going to be allowed to use a calculator. I'll give you a little calculator that just has computation, multiply by, add, subtract. If you have one of those at home, you can bring it or I'll loan you one. We have lots of them. But you're not going to be able to use a scientific, you're going to be able to use a unit circle, but not a graphing or even a scientific, because unit circle. Unit circle, yeah. So, but if you did have a calculator, because sometimes angles don't always come out to be nice and neat. So say you want to know the sine of 373 degrees. Okay? First of all, that's going to be the same as how many degrees? 13 degrees. And you know how to do that on your calculator, right? You did that in trig. So it's the same as sine of 13 degrees. And you could kind of estimate, this is a bad picture, but 13 degrees isn't very big, right? So guess, like make an estimate. If this is 1 and the ratio, and this is 13 degrees, and you're talking about the opposite side over the adjacent side, do you think that's going to be a number close to 1 or not close to 1? Closer to 0 than 1, right? So maybe like 0.1 or 2 or something like that. So you can get an idea if you're doing things right by looking at the picture. So if you grab your calculator and you go the sine of 13 degrees. Hello, sin. First of all, you got to make sure you're in the right mode. All right. So everyone, when they take pre-calc, trig, they always get problems wrong because they go, oh, I think I was in the wrong mode the whole time. You have to double check when you're using a calculator. So if you're in degree mode, you want to make sure you're in. So if I want this sine of 13 degrees, okay, sine of 13, second quit, so now I'm in degree mode. I'm going to go sine of 13, and I get out 0.22. So that's pretty close, right? I said it had to be a number closer to 0 than 1, somewhere in there, which should be the same as the sine of 373, which demonstrates that this has a period of 2 pi or 360 degrees, right? Now, if you want to do something in radians, the cosine of, for instance, 2 pi over 3, would you expect a negative number or positive number? Cosine of 2 pi over 3. Negative number or positive number?
Positive.
You'd expect a negative number because cosine is negative in the second quadrant, right? So first of all, you're going to grab your calculator. You have to hit, you don't have to do this, but I do. Okay? So I'm going to go to mode. Make sure this is in radians. If you don't see any degree symbol, you're in radians. And you go down to radians. And hit enter. So now I'm in radian mode. And then I go cosine. Second click. Cosine of 2 pi is right over here somewhere. I can never find it. Above the arrow button. Is that it? Cosine of 2 pi. You don't plug in 3.14, you plug exactly in pi, okay? Divided by 3, and you close the parentheses. And I'm going to guess that, don't tell me, that this number is don't tell me, 0.86 something. Oh! I was wrong. I was thinking root of 3 over 2. So, cosine of 2 pi over 3, that's right. That's up here, right? So that's a 60-degree angle. If it was a 30-degree angle, then it would be 0.86 something. Okay? So we're over here and we get out negative 0.5. Now what if they say, like, here's a tricky one. What if I said cosecant of 1.7? What the heck does that mean? No, same thing. Cosecant of 1.7. Would you know how to do that? With a calculator. This would be a calculator question. Who can tell me how to do that? No? So, if you go to your calculator and you look, hey, where's the cosecant button, right? There's no cosecant. It's not the -1 button. It's not anything like that, okay? So, it's not the second sine button. That means the second sine button, we'll talk about it in a day or two. Okay, that's the inverse sine, which means the angle whose sine is something, okay? So what you have to do for cosecant of 1.7, cosecant, you remember, that's equal to 1 over sine. So that's equal to 1 over the sine of 1.7. All right? And if you don't see any degree symbols near it, that means it's in radians. So I know that a radian is about 57 degrees. So this is maybe a little more than 90 degrees. I don't know how many degrees it is, but it's 1.7 radians, not degrees. So we're just going to go to what I could do is go to something. If I've been way longer than 15 minutes and you don't want to learn anything, then you could just step outside and sit in the hall. Okay? But I am here to teach you math. All right? My job. Thank you. Okay, so sine, so this is the way you can do this on your calculator. You could just go sine of 1.7, like that. You can hit enter, and then you can hit this button, which will give you the reciprocal, x to the -1. So if you hit this button right over here, x to the 1, answer, x to the 1.
Isn't that the inverse?
That, what?
Isn't that the inverse the same as the inverse?
No, inverse sine is this means the reciprocal, okay? No, yeah, the inverse function is something to the negative, but that's not what that means. That means the reciprocal. So, or you could just do 1 divided by, because that's a little confusing, of sine of 1.7, like that. And then you'll get the answer, same answer, 1.08. So what that tells me is that 1.7 radians is really close to how many degrees, if this number is coming up to be 1. Where is sine equal to 1? Where is sine, how many degrees? 90 degrees. So I think that 1.7 radians is really close to 90 degrees. Yes?
As far as the test you're saying we're not allowed to use that kind of calculator in the scientific, are you going to hold?
I'm not going to give you these kind of questions.
Okay.
Yeah, I'm not going to. But I would actually find the cosecant of Oh, thank you. We need more distractions. Thank you. All right. So, whoops. What happened?
I don't know, you pretty far.
So, but you would have to find, like, say, cotangent. Let's just do this. 7 pi over 4 exactly. Okay? Could you do that without a calculator? With just your unit circle? What's that equal to? Well, what's it equal? How could I figure it out? Cotangent is the same as what? How could I write that as a tangent? That's equal to 1 over tangent, right? So that's equal to 1 over the tangent of the, well, stop. Stop, it's doing that thing again. Just gets its mind of its own. Stop. My beautiful lesson is, it's there, I can fix it, okay? So you could do 1 over the tangent of 7 pi over 4, all right? And if you look on your unit circle, where's my unit circle? I'm just gonna let's make a circle. What the heck? So here's a circle. 7 pi over 4 puts me in what quadrant? Where's 7 pi over 4? Fourth quadrant, exactly, because that's 2 pi's over 4, 4 pi's over 4, 5 pi over 4, 6 pi over 4. So that's the way I count. That's 7 pi over 4, which is when that angle is 45 degrees, okay? Or this reference angle is 45 degrees. Or that angle is 315 degrees to here, the same as 7 pi over 4. So the coordinates there are positive root of 2 over 2, comma, negative root of 2 over 2. So what's the tangent of that? What's y over x? What's this equal to? What's root of 2 over 2 over root of 2 over 2? Negative 1, okay? What's the reciprocal of negative 1? Negative 1. So that's equal to negative 1. All right, so you should be able to do that by looking at your unit circle without a calculator, okay? I'm going to write the homework up here. I'm just going to show you it on my website, but then I'm going to give you this trig cut-up puzzle to do, okay? And you have a good almost hour, right? Okay, to do this, and you have to do it in class activity. But let me just show you what the homework is so you can see it. Where is the homework? I go to index. What is that? Go to pre-calc assignments, chapter 4, and okay, I'll make it bigger. You'll see. Homework, partial. There it is. Can you see that now? Now? How's that? Page 270, 2 through 20, even 31, 36, 45, 51, 53, 74. It's just like what is a sine, what is a cosine. It's not like solving, like find all the zeros and all that stuff. It's fast, all right? They're quick little problems, okay? And then it said, what? This will definitely help you with the quiz, yes. Okay?
Jeez.
Well, yeah, I'll go over a couple of things. No, I didn't make it. All right, so I'm going to stop recording now. And 24 minutes, so I